Den dobrý, já přepřasčám, že nemluvím po polsky. My name is Michal Marek and I will present here some results which were obtained by me and my colleague from the Institute of Global Change Research, Czech Academy of Sciences. The objective of today's lecture is the impact of climate changes on forest productivity. Which arguments are supporting the importance of the landscape biosphere carbon balance? Forests are a very important player. Why? Because commonly occupied large area, important element of landscape. Forests are composed from the system of long-living organisms, trees. It means that they play the role of long-term biointegrators of local environment. Leaf area of forest is really large. It means there are the good condition for massive biological pumping of carbon dioxide. Which are limits for forest biological CO2 pumps? Carbon uptake is strongly dependent on the solar radiation input, limitation for different geographical localities. Carbon uptake is dependent on the photosynthetic performance. Photosynthesis is limited by supply of nitrogen in the assimilatory tissue, local environment, site quality. And carbon uptake is strictly dependent on adequate water supply. But it's possible to say that carbon uptake in the forest is strongly affected by foresters' phytotechnics, by foresters' actions. Here you can see the very simple figure about the carbon and water vapor exchange between the forest stand and atmosphere pedosphere. Very important is uptake of carbon dioxide via the photosynthesis and efflux of carbon dioxide via the decomposition and respiration activities. Of course, all is very strongly dependent on the solar radiation input. Current output of this biological carbon pump is really very big, amounts to practically 20 gigatons carbon dioxide per year. And the current problem of not only the forestry is the global change. And which factor of global change manifestation are particularly important? I will show you the examples from the Czech Republic. Increase air temperature. Yes, here you can see some old manifestation which is showing how really the air temperature is increasing during the last 100 years. It's really a phenomenon which is a common and which is very important. Change in solar radiation conditions is again the examples which are obtained by us on our experimental site. The solar irradiation in atmosphere clearness is not significantly changing during the recent years. It means that really the changes in solar radiation input is not so important factor. And what about the never-ending discussion of the effect of natural changes of planet Earth, solar activities, and effect of man's? Here you can see the two pictures. It's evident that temperature and solar activity is not so good coincidence. It means that really we have the differences between the solar activity and the air temperature. Changes in historical trend of air temperature and precipitation. It's the very big problem because we have a lot of evidences about the changes of air temperature during the last years, the last centuries. Here you can see the situation in the Czech Republic, where it's really evident the temperature is increasing, and what is very dangerous, but total input of precipitation is not changing. It means that really we still have the big differences between the air temperature and amount of the water in the landscape. Here you can see the current situation. It means that we have some evidences about the stagnant precipitation, and what is very important, that the changes of precipitation amount are really significant. It means that the distribution of the precipitation during the vegetation season is changing. Here you can see that we have the really significant decrease in the spring and a little bit increase, moderate increase in the autumn. Of course, from the point of view of the agriculture, from the point of view of the forest establishment, of the new forest stand establishment, the situation is not very good. Consequences of anthropogenic effect greenhouse gases emissions, here we know it very well. It means that really the increase of global fossil fuel emission is evident, and still we have no any signals about the changes of this negative trend. What about the carbon uptake and storage in the forests? Here you can see the map of the Czech Republic territory, and the forests cover about 32%. It means that really the forests are playing a very important role in the Czech landscape. Here you can see what the situation of the carbon absorption by different types of the forest during the sequences of the years. Mountain spruce stands, mountain beech stand, highland spruce stand, mountain grassland, and agroecosystem. It means that still, on the basis of ecovariance technique, we are measuring the absorption or storage of the carbon in the forest stand, in the ecosystems. And forests are still very, very important player of this exchange. When we are thinking, when we are observing the partitioning of carbon in different stages of carbon storage in the tree, you can see that we have this example here of the mountain spruce forest. Average annual net ecosystem exchange is 5 to 6 megagrams of carbon per year per hectare. Allocation of carbon in the stream is 1 or 2 megagrams carbon year per hectare. And the average participation of carbon allocation into stem as a part of whole annual net ecosystem exchange amounts of 34%. Current Czech forest limits are strongly related to global change manifestation. Two very important factors are now very big problem of the current Czech forestry. The first one is the drought, and as a consequences, bark beetle attack. What about the drought impact? Strongly affected by the forest and localization. It means there are the different effects of drought in mountains and highland forests. Here you can see the example of very critical year 2015, where really the drought of the Czech Republic was achieved the absolutely critical level. It was a really extreme drought year. And what about the response of forest? We are comparing two localities in the highlands and in mountains. Here you can see that really in highlands, the effect of the drought was evident. In the mountains, the effect of the drought was not so significant, not so drastic. When we are comparing the net ecosystem exchange, ecosystem respiration, the gross primary productivity, we can see that really the mountain spruce up to thousands meters above sea level really surviving the drought in a better mode comparing to highland spruce. Here you can see the total calculation. It means that this effect of drought was not so drastic in the mountains forest. It's 7 tons of carbon per hectare comparing to 4-5 tons of carbon in highland forests. when we are making some comparison, some table about the drought responses in spruce which are located at different altitude, you can see that really the mountain spruce are not so drastically affected. As the red numbers are showing the percentage of the changes comparing to classical normal years. You can see that really the highland spruce forest decrease the carbon storage about 10–20%. Very useful and very promising tool for the observation of forestry's responses to the environment are the application of automatic dendrometer. We really established a very nice network of these automatic dendrometers which are measuring the increase or the changes in the radius of the stem. Here you can see the set of the years where we have the gross primary production, net ecosystem exchange, and stem increment. And here you can see that for this critical, extremely dry year 2015, the stem increment was extremely low as a response to the deficiency of water in the soil. Spruce stem radial increment response to water deficit is again related to altitude. Here you can see the year 2013 as the classical normal. Different colors of the lines are indicated forest stands at a different altitude, and you can see that in the strong drought year 2015, the decrease, this is the blue line, of the increment was really extremely high in the highlands forest spruce stand. It means what is evident? It's evident that the current climatic conditions in the Central European regions are not suitable for growing Norway spruce at lower and middle altitudes, and that forest management must react immediately to this situation. Not suitable conditions at this lower altitude. Norway spruce really is not able to survive this attack of global changes at these localities. That we are really in the area of very important and very deep drought effect is showing on this long-term tree ring analysis of the spruce. Here you can see that really we are not only measuring the tree rings, but we are measuring a composition of carbon and oxygen isotopes. And you can see that we started with these curves in the Celtic area, Celtic epoch, and here you can see at the end, it means its current situation, and it's really possible to say that agriculture drought overcomes in the years 2015, 2018, all drought periods during the last 2 millennia. It means that really we are in the epoch of extremely big impact of the drought. What about the bark beetle impact? The bark beetle impact is really strongly connected to the drought condition, and it's strongly connected to the localization of the spruce stands. It means that really it's true that the highland spruce stand in the Czech Republic are extremely sensitive to the effect of bark beetle attack. Here you can see the main area where the bark beetle attack was recorded during the last years, and I will show you the situation which is, I will show you the concrete spruce stand situation. It's 2017 started, slowly the attack. 2019, you can see this small area which are attacked by bark beetle. Here, the 2020, extremely big area. And now you can see how really quickly this destruction of the spruce stands as a response of bark beetle was recorded. This problem is related to the not very nice situation when we are really calculating that forests are a carbon storage. The situation was changed. You can see that in the last years, the Czech forests are not the storage of the carbon, but are sources. It's really a very bad situation from the point of view of our total carbon balance calculation. At the end of my lecture, I will try to summarize some concluding remarks. Future progress of forestry responses to the impact of global climate change in the Czech Republic, according to the results of current climate models scenarios which describe the development of climate in the Czech Republic, is possible to express following final statements. The first one, climate of the Czech Republic is really warmer. Deficiency of water during the growing season starting to be every year reality, especially because this changing of distribution of the precipitation. The traditional forestry based on spruce forest monoculture starting to be practically impossible or extremely complicated. The climate-smart forestry could be a new alternative of forest social role, especially under the current situation when the carbon sink in the Czech forest is decreasing. Thus, intensive forest-smart phytotechnique, especially intensive and creative thinning, reintroduction of copy systems and selective silviculture are new challenges for forestry under the impact of global change. Thank you very much for your attention.